So welcome everybody to this latest video on 162 Maths, and in this video we'll be looking at continuing with functions with a focus on inverse functions by going through some exam style questions. So before we get started, just a little reminder that if you want to have a go at these questions on your own, then you can download the question sheet by clicking on the link in the description. Now there are going to be quite a lot of questions that we go through, and most of them are going to be very repetitive with regards to the content, because you do find that these questions do tend to be relating to inverse functions are repetitive. So the first one will generally involve you working with a potential function, substituting a value in, then you'll be asked to find the inverse function, and then thirdly you'll be asked to find a value that goes into the inverse function. Obviously you can have some more problem solving questions, one's notably using composite functions, but again that's a separate video. So if you're wanting help on composite functions, then I recommend you watch that. So let's get started on question 1. So on question 1 it says if f of x equals 3x minus 2, find the inverse function. So for this, again going through the steps, we want to make the equation equal to y, and then from this we then want to make x the subject. So I take the y over and then take the minus 2 over to make positive 2, and then get rid of the 3. And then once you've made x the subject, you then replace x with inverse function x and replace y with x. So what you end up with is f minus 1 of x equals x plus 2 over 3. Then for b, we're just substituting 13, so sub x equals 13 into our inverse function. So that's going to be 13 plus 2 over 3, which equals 5. Moving on to question 2, it says if f of x equals 2x, which expression represents the inverse function? So again, we make the function equal to y, and then we're going to make x the subject, and then replace the y with x. So we're looking for x over 2, which is option C. Moving on to question 3, it says f of x equals 2x, find f of 2. So here we're doing is substituting 2 into 2x plus 1. So that's going to be 2 times 2 plus 1, which equals 5. For part B, again we make the function equal to y, and then we make x the subject. So y minus 1 equals 2x, y minus 1 over 2 equals x, which then becomes the inverse function of x, which is x minus 1 over 2. And then for C, we're just substituting x equals 7 into our inverse function. So I've got 7 minus 1 over 2, which is 6 over 2, which is equal to 3. Then moving on to question 4, it says f of x is x squared minus 1. Find, for A, we need to find f of 5. So here all I'm doing is substituting x equals 5 into f of x, so I get 5 squared minus 1, which then equals 25, take away 1, which gives me an answer of 24. The next question then says work out the inverse function. So again, I make it equal to y. Then I take the minus 1 over, so I have y plus 1 equals x squared. And then make x the subject, so I square root y plus 1 equals x. That's going to be a plus or minus. So then the inverse function of x is going to be plus or minus x, write y, plus 1. Then for when substituting 8 into this, then what we're getting then is sub x equals 8 into our inverse function of x. So here I'm going to have plus or minus square root of 8 plus 1, which then leaves me with plus or minus 3, because then that then becomes plus or minus root 9, which then gives me plus or minus 3, or just positive 3. Moving on to question 5, it says given that f of x equals x over 2 plus 5, find f2. So it's going to be 2 over 2 plus 5, which is 1 plus 5, which is 6. Then for B, we've got y equals x over 2 plus 5. So I take the 5 over, and then multiply everything by 2, so end up with 2y minus 10 equals x. So the inverse function of x is going to be 2x minus 10. And then for c, all I'm doing there is substituting x equals 5 into the inverse function. That's going to be 2 times 5 minus 10, which gives me a value of 0. Moving on to question 6, let's just make that question a little bit bigger. So here we've got f of x equals x plus 3 over 2. So for the first part, we're just substituting x equals 2 into this function. I've got 2 plus 3 over 2, which is 5 over 2, or 2.5. Then for b, inverse function, so y equals, get rid of that, x plus 3 over 2. So I take the 2 over, so I end up with 2y equals x plus 3. So then 2y minus 3 equals x. So my inverse function is therefore going to be 2x minus 3. And for c, substituting x equals 12 into our inverse function, I've got 2 times 12 minus 3, which gives me an answer 21. Moving on to question 7. So it says we want to work out the inverse function. So again, we make it equal to y over 2. Take the 2 over first. Then we take the 7 over. And then we cube root it. So then from this, we get the inverse function of x equals the cube root of 2x plus 7. Now, if you left y in your answer, you are going to lose the mark. So you always need to make sure that you do replace the y with an x and replace the x with the inverse function notation. So then from this, what we've got to do then is substitute x equals 28.5 into this, into our answer for a. So it's going to be the cube root of 2 lots of 28.5 plus 7. And 28.5 times 2 gives me an answer of 57. So it's going to be the cube root of 57 plus 7, which gives me the cube root of 64, which is 4. Moving on to question 8. So again, working out f of 3. So do 3 squared minus 3 over 2, so that's 9 minus 3 divided by 2, so that's 6 over 2, which is 3. Then working out the inverse function, so y equals x squared. And again, I'd always write down the steps. The marks will be sort of wanting you to do these steps, and just making sure that you're not making any silly errors. The square root of 2y plus 3 equals x. Then my inverse function of x equals the square root of 2x plus 3. Then substituting 11 into that. So I've got 2 times 11 plus 3 square rooted, which gives me 25, which gives me plus or minus 5. Moving on to question 9, it says given that f of x equals x cubed over 4 plus 6, find f of 4. So just substituting x equals 4, so it'd be 4 cubed divided by 4 plus 6. Well, that's going to leave me with 4 squared plus 6, which is 16 plus 6, which is going to give me 22. Then finding our inverse function, so y equals x cubed over 4 plus 6. So y minus 6 equals x cubed over 4. Multiply everything by 4 by taking that to the other side, so end up with 4y minus 24 equals x cubed, and then cube root all of that, which is 4y minus 24 equals x. So that leaves me with the inverse function of the cube root of 4x minus 24. Now, a common question you get asked is, if I didn't multiply at this stage here, could I use brackets? So could I write that as, let's say, 4 y minus 6, and that would be absolutely fine. The only reason why I'm expanding it out is just to make it easier if this was on a non-calculated paper. So moving on to C, we're just substituting 8 into our answer for B. So I've got 4 lots of 8 minus 24, all cube rooted. So that's going to be the cube root of 32 minus 24, which leaves me with the cube root of 8, which is going to give me the answer of 2. Now the reason why it's not plus or minus 2 is because we're cubing. The only way you can get 8, positive 8, when you're cubing a number is if the original number was 2. Moving on to question 10. And so looking at this, we've got two functions. So the question is saying work out f of 6 plus g of 3. So here, a, I'm substituting x equals 6 into f of x. So that's going to be 6 over 3 minus 1 plus, and then substituting 3 into g of x. So it's going to be 2 lots of 3 minus 5. So working out the number in red, so that's going to be 6 divided by 3, which is 2. Take away 1 is 1. And 2 times 3 is 6. Minus 5 is 1. So it's going to be 1 plus 1, which is 2. Then we need to work out the inverse function of g and then substitute 7 into it. So here, what we need to do is find the inverse function of g. So y equals 2x minus 5. So y plus 5 equals 2x. So then y plus 5 divided by 2 equals x. So inverse of g equals x plus 5 divided by 2. So from this, inverse g of 7 is going to be 7 plus 5 divided by 2, which is 12 over 2, which gives me an answer of 6. Then for the next one, if I then need to work out for C, I then need to work out what the inverse function of y is, of f, sorry. And that's going to be, so working this out, y equals x over 3 minus 1. So y plus 1 equals x over 3. So then we've got 3y plus 3 equals x. So the inverse function of f is going to be 3x plus 3. So then substituting each of those in, well, g of x I've already worked out as being 6. And that's from part B. So f of 1, well, that's going to be 6 minus, and then it's going to be 3 times 1 plus 3, which is 6 minus 6, which equals 0. Moving on to question 11. So this is where we start moving on to more complicated inverse function questions. And the reason for that is because in your function, you now got x's on both sides. So looking at part A first, all we need to do here is substitute x equals 2 into our f of x value. So here, let's have a look at what this is. So here what we've got is we're going to have 2 plus 5 divided by 2. So that's 7 over 2, which is 3.5. Then the inverse function of 2, well, this here is our inverse function. So then to work out f of the inverse function of x when it's 2, so we've got 5 over 2 minus 1, because here x equals 2, and that leaves me with 5 over 1, so the answer then is just 5. Moving on to question 15, and let me just reposition that just so we've got it on the screen. It says, given that any function of the form f of x equals x minus a over x, where a can be any value, we'll have an inverse of the form f of x, or the inverse function of x equals a over x minus 1. Find the inverse of f of x equals x plus 4 over 4. So what we need to do is we need to compare this to this. And if we compare those two, then what we notice is that a equals 4. So what I then need to do in this particular question is sub a equals 4 into a over x minus 1. So from this, all we've then got is then 4 over x minus 1. And there is our final answer. Moving on to question 13, so let me just make that a tad bit bigger. So here, so this is just what we do here because we've got x on both sides. So for this, again, process is exactly the same. So I make it equal to y. I then take the x over to the side, so I end up with xy equals x plus 3. Then you want to have x's all on one side, so I have xy minus x equals 3. I then want to factorize this, so I've got x y minus 1 equals 3, and so x equals 3 over y minus 1. So from this, now that I've made x the subject, I can then just swap what I need to, so then it becomes that. Moving on to question 14, it says, given that any function of the form ax plus b over x, where a and b can be any values, will have an inverse of the form of b over x minus a. Find the inverse of f of x when f of x equals this. So looking at this, what we notice, so what we want to compare is this to this, in which there my a equals 3, so comparing the coefficients, and b equals 5. So from this, what we then need to do is substitute those numbers into this, in which then I get my inverse function of x equaling 5 over x minus 3. Now this question would generally be worth about 1 or 2 marks, whereas if you were not given any of this information, just going straight from working out the inverse function of f of x when it equals 3x plus 5 over x, it would be worth considering more marks. Moving on to question 15. So again, all we need to do is work out the inverse function. So here I've got x's on both sides, on both twice. So I make it equal to y. I then take this x over to the side, so I get xy equals 2x plus 1. I then take this 2x over to the side, so I get x plus xy minus 2x equals 1. I then factorize and then take the bracket over to the side. And then from this, I then do my replacement. And there is my inverse function. Then moving on to question 16. So again, very, very similar. So make it equal to y. Then take the x over. Then take the 3x over. Then factorize. And then take the bracket over. And then from this, do the replacement, in which your answer should be 2 over x minus 3. Then moving on to question 17, again, very, very similar. So make it equal to y. Then take all of this over to the side, so end up with y, x minus 5 equals 2x. Expand the brackets. And then swap these two things around. So I get xy minus 2x equals 5y. Then factorize. And then take the bracket over. And then do the replacement. And there is my final answer for that one. Then for the very last example, let's just have a look. So it says functions of g and h are such that it says where a and b are constants, h of 3 equals 26, and the inverse function of g equals 21 equals h, the same as when you substitute 1 into h. Find the values of a and b. So let's have a look at this particular question. So let's work with this first. So if I substitute this into this, then I know that when x equals 3, that h of x equals 26. So substituting it in, I get a multiplied by 3 plus b equals 26. So if I just neaten that up, I get 3a plus b equals 26. And there's not much else I can do with that, so I'm going to leave it there. The next thing for me to then do is work out the inverse function of g. So working out the inverse function of g, so I get y equals 2x plus 5, y minus 5 equals 2x, y minus 5 over 2 equals x. So the inverse function of g is going to be x minus 5 over 2. Now when I substitute 21 into this, then that's the same as when I substitute x equals 1 into h. So here from this, what we've then got is using, let me just kind of color code this from this here, which I'm going to be using this and what's written in the red box. Or let's change the color because I've already used red twice. Let's change that to pink box. Then what I end up with is 21 minus 5 over 2 equals, and it's going to be when x is 1, which is just going to be a plus b. So simplifying the left hand side, 21 minus 5 gives me 16 over 2 equals a plus b. So a plus b equals 8. Now what you should notice is that using these two things here, it then becomes a simultaneous equation. So I've got 3a plus b equals 26, and I've got a plus b equals 8. Now as you can see, my b's are the same and they're both the same sign, so I take away the two equations, in which I get 2a equals 26, take away 8, which is 18, so a equals 9. Now if a equals 9, using a plus b equals 8, I get 9 plus b equals 8, so b equals minus 1. And there are my two answers for A and B.